Hi all, in this video we are going to learn about voltage dividers under DC circuit theory. This is our last video on this playlist. Voltage dividers. Voltage divider circuits are used to produce different voltage levels from a common voltage source, but the current is the same for all components in a series circuit. So which means here this is a basic symmetric of the voltage divider. So here the supply voltage is Vs. So we can interconnect the Vs supply like this. So the total voltage across these two resistors will be equal to the Vs. But here you can see that the supply current I will pass through these two resistors because the two resistors are connected in series form. Therefore, the same amount of current will pass through these two resistors. So this is what they have mentioned here. Resistive voltage divider circuit. So here is our circuit. For this circuit, we need to find VR1 and VR2 because here we know the total voltage, which means the supply voltage is Vs. From this supply voltage we can take two or more voltage variation or voltage levels as our requirement. So here there are two resistors are connected in series form. Therefore we can take two different voltage levels from this circuit. So here those voltage level are VR1 and VR2. So now we are going to take the relationship to find out the VR1 and VR2. So the initial step is we know the total voltage. The total voltage is Vs. So the Vs is equal to, here according to the KVL, Kirchhoff's voltage law, the total supply voltage Vs will be equal to VR1 and VR2. Then again using the Ohm's law we can take another relationship for VR1. So the VR1 again that will be equal to the current flowing through the R1 resistor is I. So I into R1. Here VR2 will be equal to I into R2. Then again for the first equation we can substitute the value here. Vs will be equal to, for the VR1 we can write as I into R1 plus for the VR2 we can write I into R2. Then again we can take I as common for this equation. So Vs will be equal to I into here R1 plus R2. Then here we can take out I. Therefore the I will be equal to Vs over R1 plus R2. But what we need is, here we need the relationship for VR1 and VR2. So now the VR1 will be equal to I into R1. So now, so you can substitute for the value I here. So the I will be equal to Vs over R1 plus R2 into R is, for the R here R1. Likewise, we can take another relationship for the VR2. The VR2 will be equal to I into R2. So the I we can again write as Vs over R1 plus R2 into R2. So here are the relationship for the VR1 and VR2. So here is an example question. How much current will flow through a 20 ohm resistor connected in series with 40 ohm resistor when the supply voltage across the series combination is 12 volt DC? Calculate the voltage drop produced across each resistor. So we can draw the circuit like this. Here there are two resistors are connected in series and it is connected with 12 voltage DC supply. So the resistivity values are 20 ohm and 40 ohm. So as we learned previously, here the supply current we can take as I. So the initial step we have to do is we have to find the total equivalent resistor. So the equivalent resistor RT will be equal to 20 ohm plus 40 ohm. Oh, that will be equal to 60 ohm. So again we can take the relationship for the I. I will be equal to the supply voltage over, supply voltage is Vs over total equivalent resistor. So RT, that will be equal to, the Vs is 12 voltage, RT is 60 ohm. So equal to 0.2 amperes. 0.2 amperes. Then now we can take the relationship for the VR1. So we can simply find the value for VR1. That will be equal to I into R1. We know the value of I as 0.2 ampere and R1 is 20 ohm. So that will be equal to 4 voltage. Likewise, we can find VR2 also. The VR2 will be equal to I into R2. So that is equal to I is 0.2 ampere, R2 is 40 ohm, equal to 8 voltage. So very easy question. Voltage divider example number 2. Three resistive elements of 6 kilo ohm, 12 kilo ohm and 18 kilo ohm are connected together in series across a 36 volt supply. Calculate the total resistance, the value of the current flowing through the circuit and the voltage drop across each resistor. So here the data given as Vs as 36 voltage, R1 as 6 kilo ohm and R2 as 12 kilo ohm and R3 as 18 kilo ohm. So simply we can draw the circuit like this. Three resistors are connected in series with a voltage source. So the V as 36 voltage, R1 is 6 kilo ohm, R2 is 12 kilo ohm, R3 is 18 kilo ohm. So here the supply current I will be, to find the supply current, the first question is calculate the total resistance. So the RT, total resistance RT will be equal to, here addition of these three resistivity value. Here three resistors are connected in series. Therefore the equivalent resistance RT will be equal to 6 kilo ohm plus 12 kilo ohm plus 18 kilo ohm. Altogether that will be equal to 36 kilo ohm. Then the second question is the value of the current flowing around the circuit. So they are asking the value of I. So the I will be equal to, here I will be equal to Vs over RT. Vs, we know the value of the V as 36 voltage. RT is 36 kilo ohm. 36 kilo ohm means 36,000 ohm. So that will be equal to 1 milliampere. 1 over 1000 ampere. So we can write as 1 milliampere. So the third part is voltage drop across each resistor. So to find the voltage drop across each resistor, so that we can write the equation VR1 will be equal to Vs over R1 over RT. So this is the common equation RT. So now we can substitute the value Vs. So we know the value Vs is 36 voltage into R1 6 kilo ohm over RT 36 kilo ohm. So altogether that will be equal to 6 voltage. Likewise, we can find VR2 also. The VR2 will be equal to Vs over R2 over RT. So here 36 into, for the R2 we can write 12K over, for the RT 36K. So that is equal to nearly 12 voltage. So if we solve this, we will get the value of 12 voltage. Likewise, VR3 will be Vs into R3 over RT. So if we substitute the value and solve that, we will get the value of 12 voltage. So this is very basic question, very easy question. Voltage divider circuit. So here is a type of voltage divider circuit, but here all the resistors are connected in series form. So here according to the KVL, we can write as the supply voltage or the terminal voltage will be equal to the sum of all the voltage drop across each resistors. Here there are 3 resistors are connected in series form. So according to the KVL, we can write as the supply voltage, that is 36 voltage, that will be equal to the voltage drop across each resistors. So the voltage drop across the resistor R1 is 6 voltage. The voltage drop across the resistor R2 is 12 voltage, and the voltage drop across the resistor R3 is 18 voltage. So we can write as 36 equal to 6 plus 12 plus 18. So that is exactly equal to 36 voltage. So that 36 voltage is what we call as the supply voltage, or another word we can call as the terminal voltage. Supply voltage Vs, or we can call as the terminal voltage Vt. So here the key point you have to notice that the largest resistor produces the largest voltage drop. So comparatively, R3 has the largest resistance or the resistivity value. Here R3 is 18 kilo ohm. So this R3 contain highest voltage drop comparatively. Here the R3 has higher voltage drop. Here the voltage drop is 18 voltage. So this is the key point we have to note down from this circuit. Voltage tapping points in a divider network. So in this circuit there are 5 tapping points are there. So by adjusting the tapping position, we can take multiple voltage level or multiple voltage drop as per our requirement. So I will show with an example question. Voltage divider example number 3. Calculate the no load voltage output for each tapping point of the voltage divider circuit above. If the series connected resistive network is connected to a 15 voltage DC supply. So the supply voltage Vs already given as 15 voltage. The initial step we have to do is we have to find the equivalent resistance. So here to find the equivalent resistance across this terminal A and E, here these 4 resistors are connected in series form. So therefore we have to add all the resistivity value. So the RT will be equal to R1 plus R2 plus R3 plus R4. Here R1 is 8 kilo ohm, R2 is 4 kilo ohm, R3 is 2 kilo ohm, and R4 is 1 kilo ohm. So altogether it will be 15 kilo ohm or 15,000 ohm. Now we have to find VAB or VR1. Here the VR1, which means the voltage drop across the resistor R1. Another way we can take as VAB, because this VR1 is connected in between these 2 tapping points, point A and point B. Therefore VR1 we can write as VAB. So that will be equal to Vs into R1 over R2. As I said previously, we can directly use this equation. So the Vs means the supply voltage is 15 voltage and the R1 is 8 kilo ohm. 8 kilo ohm means 8000 ohm and RT is 15,000 ohm. So that will be equal to 8 volts. Likewise, we can find R2 also. The R2 will be 4 volts and R3 will be 2 voltage and R4 will be 1 voltage. So for an example, I am asking you a question. If you want 12 voltage, so what will we do? So what are the tapping point you have to connect with your circuit? Here, to get the 12 voltage, we can consider VR1 and VR2 in series form. So here the total voltage will be 8 plus 4, that will be equal to 12 voltage. So by connecting VR1 and VR2 in series form, we can get the required 12 voltage supply. So to get the 12 voltage supply, we have to connect the input terminal of the circuit in the tapping point of A and point C. Then after we can get continuous 12 voltage supply. Previously we have found the value of VAB, VBC, VCD and VDE as follows like this. So now our question is, calculate the load voltage output from between point B and point E. So here is our tapping point B and here is our tapping point E. In between B and E, there are 3 resistors are there. So if you want to find the voltage in between point B and E, we can directly write as Vs into, here we want the voltage drop across point B and point E. So we have to add all these 3 resistors. So here the R2 is 4 kilo ohm, R3 is 2 kilo ohm, R4 is 1 kilo ohm. So likewise here the Vs into, you have to add all the 3 resistors here, R2 plus R3 plus R4 over total equal resistor. So now we can substitute the value. So the Vs is 15 voltage and the R2 is 4 kilo ohm, R3 is 2 kilo ohm, R4 is 1 kilo ohm over RT is 15 kilo ohm. Then that will be equal to 7 volts. So the voltage drop across point B and point E is 7 voltage. Voltage divider example number 4. Using Ohm's law, find the values of resistors R1, R2, R3 and R4 required to produce the voltage levels of minus 12 volt, 3.3 volts, 5 volt and plus 12 volts. If the total power supplied to the unloaded voltage divider circuit is 24 volts DC and power is 60 watt. So now we know the supply voltage Vs is 24 volts and the power P is 60 watts. So now we know the voltage and we know the power. So from these 2 parameters we can find the supply current or the loop current. The loop current I can be defined from this equation. I will be equal to P over V. Here we know the power 60 watt and the voltage is 24 volt. So 60 by 24 will be equal to 2.5 ampere. So we know the supply current 2.5 amperes. So our question is, we have to find R1, R2, R3 and R4. So to find the R1, here the R1 is connected in between these 2 tapping points, point A and tapping point B. So the voltage in the tapping point A is plus 12 volts and the voltage of the tapping point B is plus 5 volt. These two voltages are calculated with respect to ground voltage. From this 0 ground voltage, these two tapping volts are connected or calculated. So, using the Ohm's law, R can be calculated by R will be equal to delta V over I. Here the delta V mean difference of the voltage. So here the voltage difference mean here this point plus 12 volt at the point B plus 5 volt. So the voltage difference is 12 minus 5. So here R1 will be VA minus VB over I. So the VA is 12 volt minus VB is 5 volt over I can be substitute as 2.5 ampere. So that will be equal to 2.8 ohm. Likewise, we can find R2. Here R2 connected in between these two tapping point B and tapping point C. Here tapping point B is 5 voltage with respect to ground volt, and here the tapping point C connected with respect to this ground volt, the voltage is 3.3 volts. So the voltage difference is 5 minus 3.3 over the loop current is 2.5 ampere. So that will be equal to 0.68 ohm. Likewise, we can find R3 also. R3 will be 1.32 ohm and R4 will be 4.8 ohm. So very easy question. Capacitive reactance formula. Before analyze this capacitive reactance formula, we have to remember the basic concept is we can store the energy by three different components such as resistor, inductor and capacitor. Till now we have done the calculation part by the resistive connected voltage dividers. Now we are going to move capacitive connected voltage divider circuits. So to analyze the capacitive connected voltage divider circuit, here this equation is very important. We have to remember this equation before we move to the calculation part for the capacitive reactance or capacitive connected voltage divider circuit. So here the XC is the reactance of the capacitive. So the unit is ohms, and so XC that will be equal to 1 over omega C. Omega means 2 pi F into C. 2 pi. Pi is a numeric constant. So that the constant value is 3.142. And F is the frequency. The unit of the frequency is hertz. And C is the capacitance. The unit is farad. Capacitive voltage divider. Using the two capacitors of 10 microfarad and 22 microfarad in the series circuit above, we can calculate the RMS voltage drop across each capacitor in terms of their reactance when connected to a 100 volts 50 Hz RMS supply. So in the question there are two capacitors are connected in series form. Our question is we have to find the voltage drop across each capacitors. So the initial step we have to do is we have to find the reactance of each capacitors. To find the reactance of each capacitors, we can use the formula as we learned in previous slide. So to find the reactance of the capacitor, the formula is XC equal to 1 over 2 pi FC. So now let's find the reactance for the capacitor C1. So XC1 will be equal to 1 over 2 pi F C1. So equal to 1 over 2 pi into F is the frequency. Frequency is 50 Hz and C1 is 10 microfarad. Here 10 microfarad can be written as 10 into 10 to the power minus 6 farad. So that will be equal to 318.3 ohm. Likewise, we can find the reactance of capacitor C2. The reactance of the capacitor C2 will be equal to 144.7 ohm. Now we have to calculate the total equivalent reactance. The total equivalent reactance will be equal to addition of each reactance of the capacitors. So XC2 will be equal to XC1 plus XC2. XC1 is 318.3 ohm plus XC2 will be 144.7 ohm. So altogether that will be equal to 463 ohm. 463 ohm. But our question is we have to find VC1 and VC2. Now we can find the VC1 from this formula. The formula to find the VC1 is Vs into Xc1 over Xct. So the Vs is the supply voltage. Supply voltage is 100 volt RMS. So 100 into Xc1. Xc1 is the reactance of the capacitor C1. That is 318.3 ohm over Xct. Xct means total equivalent reactance. The total equivalent reactance is 463 ohm. So that will be equal to 69 volts. Likewise, we can find the voltage drop across the capacitor C2. Vc2 can be calculated by using this equation. Vs into Xc2 over Xct. Vs is 100 volts. Xc2 is 144.7 ohm over Xct is 463 ohm. So altogether that will be equal to 31 volts. Now let's move for the inductive voltage divider circuits. Inductive voltage dividers are widely used for precise electrical measurements because they are rock stable and highly accurate devices. Their high accuracy, however, has been limited to audio frequency. So here this is the formula for the reactance of inductive elements. XL can be found as 2 pi FL. Here 2 pi is the constant. We know the value for the pi is 3.142 and F is the frequency and L is the inductance. The unit of the inductance is henries. Inductive voltage divider. Using the two inductors of 10 millihenry and 20 millihenry in the series circuit above, we can calculate the RMS voltage drops across each inductors in terms of their reactance when connected to a 60 volts 200 Hz RMS supply. So here there are two inductors connected in series form. Our question is we have to find the voltage drop across each inductors. To find the voltage drop across each inductor, we have to find the reactance of the each inductors. So the reactance of the inductor L1 can be found by using the formula 2 pi F into L1. Here 2 pi is the numeric constant and F is the frequency. We know the value of the frequency is 200 Hz and L1 is 10 millihenry. 10 millihenry can be written as 10 into 10 to the power minus 3. So that will be equal to 12.56 ohm. Likewise, we can find the reactance for the inductor L2. The reactance for the inductor L2 can be calculated by using the formula 2 pi F L2. Now we can substitute the value. Here L2 is 20 millihenry. 20 millihenry will be equal to 20 into 10 to the power minus 3 henry. So altogether that will be equal to 25.14 ohm. Then we have to find total equivalent reactance of the inductors. total equivalent reactance of the inductors can be calculated here XL1 plus XL2 because these two inductors are connected in series form. So the total equivalent reactance of the inductance will be equal to the sum of each reactance of the inductor. So the reactance of the inductor L1 is 12.56 ohm and the reactance of the inductor L2 is 25.14 ohm. So that will be equal to 37.7 ohm. But our question is we have to find the voltage drop across each inductors. The voltage drop across the inductor L1 is VL1 that can be calculated by using this formula. The formula is Vs into XL1 over XLT. Here Vs is the supply voltage. We know the value of the supply voltage is 60 volt RMS. So we can substitute for the Vs as 60 into XL1. XL1 is 12.56 ohm over XLT. XLT is total equivalent reactance of the inductors, that is 37.7 ohm. So altogether that will be 12 voltage. Likewise we can find the voltage drop across the inductor L2. So here we can substitute for the value V as 60. XL2 is 25.14 ohm over XLT, that is 37.7 ohm. So if you solve this, we will get the value for the VL2 as 40 voltages.